Hello guys, today we shall be starting first chapter of digital electronics, which is Boolean algebra and logic. This is the sheet of Boolean algebra, and as you can see this is still under process. And what I shall be doing is I will be completing the sheet as well as the videos, okay, because we are not having that much time left for the exams, so I will be speeding the process a bit, okay. So let's get started with Boolean algebra and logic gates. First of all, we are having the logic gate operations, which are AND, OR, NOT, NAND and NOR, okay. The basic thing, your AND means this dot symbol, A dot A equals to this, and A not 0 is 0. This is your null, okay. So make sure you remember these four equations over here. A dot A is A dot 1 is A, and A dot 0 is 0, and A dot A not, okay, is 0 as well. And then we have OR. This is your identity and this is your null, okay. Make sure you keep in mind. Then we are having OR, okay. These are your statements for OR. This is your null statement, A plus 0 equals to A, and A plus 1 equals to 1. Make sure that you remember these statements very well, okay. Questions are asked on the basis of these equations, and it is very easy to get confused, okay. So keep in mind, make a flashcard or something like that, so that you can view it on a regular basis and don't get confused while solving the questions. And one more thing I have to say is that these equations on this page may sound some gibberish and some puzzle, but when you solve the questions, you will know how to apply these statements, okay. Then we have NOT, which is complementation law. If it is 0, then you make it 1. If it is 1, then you make it 0. It is represented by A bar or A dash. Okay, then we have double complementation. If you perform this NOT operation twice, then you get the original your function, okay. Then we have NAND, which is AND plus NOT. Then we have NOR, that is OR plus NOT. Then we are having laws of Boolean algebra. The first law we are going to have is Commutative Law, okay. It deals with change in position of AND, OR, okay. These are the statements regarding commutation law. If you want to know what commutation law is, just keep these two statements in mind, okay. You can just change the position of variables. Then we have Associative Law, which allows grouping, okay. A plus B plus C can be written as A plus B plus C, okay. And so goes for OR operation as well. Then we have distributive laws, okay. This allows factoring or multiplying, okay. When you have to factor or multiply a given equation or given function, you use this distributive law. These are the equations that give you distributive laws example. Then we have idempotence law, which means same value. A dot A is A plus A is also A. This is your idempotence law. Then we have absorption law, okay. A plus B is given by this and this, okay. Then we have involutionary law. This is A double bar equals to A dash dash equals to A. Means what we are doing here is we are performing not operation twice, okay. So you are getting your original equation or equation variable. Then we have Boolean algebraic theorems. The first thing we are having is Demorgan's theorem. These two statements to be kept in mind, okay. Make sure you write all these equations somewhere, okay, because you need to learn this by heart, okay. There is nothing to be having some logical explanation behind. All you have to do is remember these formulas and solve the questions, so that you know how to apply these statements in a particular question. And questions have been asked in every exam. If we talk about ESC or GATE or whatever exam you can talk about based on those exams as well, then these are the things they will ask you each and every year, okay. And this section is, I can say, scoring in nature. It is not very tough. All you need to do is memorize these formulas, these theorems, these equations, these laws, and how to apply them, okay. Just practice them a bit and you're good to go. Then we are having transposition theorem. This is the statement that tells you what transposition theorem is. Here AB plus A dash C is given by A plus C, A dash plus B, okay. Then we have consensus or redundancy theorem. We eliminate the redundant term, okay. Here this is your given equation, and this equation can be written as this over here. Then we have It is applicable to equation that contains three variable, and each variable should be used twice, and one variable complemented and uncomplemented. Okay, here you can see it contains three variable. Here we have a b, a c, b c, three variables a, b and c. Each variable is used twice. Okay, here you see a is 2 times, b 2 times, c 2 times, and then we need to have a variable that is complemented or uncomplemented. Here we have a in complemented as well as in uncomplemented manner. So this is applicable. Consensus or redundancy theorem is applicable to such equations only. Now we are going to study duality theorem. This will be studied in part 2. So stay tuned.